Okay, this is the Nefio SDK meeting on January 9th, 2024. So actually, before I get started, anyone has any agenda items that you want to discuss? I'm guessing not. So okay. I mean, I was trying to write something a little more elaborate, but then I guess it's a little. Otherwise, it probably doesn't oversize step SDK a little bit. So kind of stop somewhere. I think when we had the meeting the day after the ONE summit, one of the topics I was trying to talk about is the evolution of the operator, but that didn't get voted in. So part of that was what I actually want to talk about. Anyway, so one of the difficulties, I guess, up to this point of the SDK, one of the major topics that's been kind of dominated the entire SDK discussion is how do we support Helm? And if you Google Helm versus operator, which obviously doesn't mean this is authoritative, but PageRank means that this is the most reference. So what this particular site said that is you use the Helm to simplify your deployment, whereas your operators is taking over all the things that you would otherwise have to do as an operator, a human operator. You wanted the Kubernetes operators to automate that process to help you actually get away with doing things that are tedious and manual. And so with that, going back to our current FreeFlyGC operator, I can't really speak for AI because I haven't actually looked at it. The FreeFlyGC operator that we have for R1 and 2, when I started writing it last year, it was based on the Helm charts from Orange towards 5GS. And I basically do a Helm template off of that charts, and that's what is being dumped. They have a values.yaml already as part of it, what it is. So, I just write code to get to that point. And based on whatever we finally finalized as our CLD, as the NF deployment, basically, or UPF deployment, which wraps NF deployment back in R1. And it because of this, it owns all the Kubernetes resources. We laid out the entire constructions of the deployments and config maps, and for SMF and MF we have servers, and then it does a API call directly when this is constructed based on what is actually in the NF deployment, and then in terms of when it executes, it actually invokes the APIs directly to Kubernetes API server, so it also does an execution engine. So what it does is three things. If you really break it down, one is take the Nefio CLs and then generate as much as possible the content of these things, of these Kubernetes resources, and the configurations, by the way. So that's actually important too. The config map obviously contains the configurations, the network function configurations that is needed to make the network functions run. And two, the deployment template is based on the Helm charts, or the config map template, which really isn't much. It's based on the Helm charts, and servers, which also isn't much. It's based on the Helm charts. And then the execution itself, which once you constructed the structure, you invoke the API calls, and that's why did we do something like this? The motivation at that time was, and that really doesn't change too much, which is, if you remember the swim lanes things that I think all of us seen many times, swim lane 3, which is the network function configs, we kind of squarely put that into something that belongs to network functions vendors to build. And then at that time we said this is they only own the operators, and everything else probably free reigning. And then for FreeFiGC, unfortunately, the network function configurations are text based, and then we wrap it up into the Helm charts, wrap it up to config map, and the executions of the FreeFiGC network functions requires that the full configurations is to be in text, loaded somewhere in text for them to read. You point them into where the configuration is, and then at the time the process start running, they read the configurations. So there's no dynamic configurations. There's configurations sitting there statically, read once when the network function started, and we wrap it into config map, which is logical because any text things we usually wrap it in config maps, and then also the Helm charts does. And config maps, something that you mounted, particularly because when we execute the container, we already point them to the configurations. So the config map needs to be mounted in the container specifications in our deployment. So in that case, even because of this, even deployment needs to be fully owned by the operators. Because if you logically have the network function operators owns the configurations, they're the only one who knows how to build a FreeFiGC specific configurations based off of Nephew CLs. Then logically they would have to also own deployment, because otherwise there's no way to mount the config map before the deployment is constructed. So that's the motivation behind why we did something like that. And because of this, logically, the operator is built today such that the executions of the construction of the deployments, or the Kubernetes built-in resources, let's do it that way. So we call those infra. If you refer back to the swim lane, this infra things are owned by the operators. The execution of this deployment pieces are being done by the operators, and obviously generating of the configurations are also done by the operator. What is wrong with that? So we gone out of business, and then we had a original R1 release date, and then at that 1 week, Tal did a very last minute change to restructure the FreeFiGC operator, which is great. But he also conveniently upgraded our FreeFiGC to the latest version, which is already supported by Helm, by the Towards 5JS Helm charts. But then many things broke. Unit test works, but then everything else worked. And because the deployment actually changed a little bit, not that much. For UPF. Part of this is because I wrote UPF first back in August last year. Yeah. And then since then, obviously, and then we used the ONE Summit. And then throughout this, when Denny's took over, we never actually upgraded the config versions. So the config is actually very outdated. And once that upgrade happens, the config map change is pretty drastic. We kind of get rid of the full templates, rewrite the whole template, and the mappings are pretty similar. So going from the UPF deployment back into what the content for config map inside the UPF config map is actually pretty similar. What they change more than anything is the ordering of the configurations. Like they put the N4 and a different tag names and all that stuff. So functionally, it's not a problem. The functional meaning that mapping of the NF deployment, we don't have to do any last minute change of NF deployment to get more parameters in or anything like that. But then you have to rewrite the entire template. And then rewrite the code to do the mapping, because the tag names change too. And then so the operator therefore makes the major updates, not the TAL updates, but then the updates afterward. make it work. Which, as you said, we changed the resources templates, and then we absolutely majorly changed the NF configuration templates. But then, so that's kind of like an epiphany for me. When we do this, if you compare that with like Helm charts, what do you do with Helm charts? What probably the orange guys did is take the latest 3.5GC, make sure it works on their configurations and their setups, on just changing the charts, update the values, and then roll it out, test it, and then push it out to Git, to make it available in public. But then when we do that, the corresponding things that we have to do for an FTO is, you have to change the code, both the template codes and the templates of the Kubernetes services and the configurations. Templates needs to be changed, and because of that, the code that actually does the mapping of that needs to be changed. And obviously, this is code, so you have to push it to Docker, and then if you imagine we are pushing that onto a deployment scenario, a real deployment scenario that we have to qualify, we have to go through unit tests and CI pipeline, put it onto Docker, roll it out. And then they would do the rest of the stuff, which you would have done anyway for Helm, which is to verify that the chart still works. But there's like a long process of releasing code and all that stuff before you get to that. So I would make an argument that because of this, whatever we're doing today, using the operator-based things to do so much of the deployment, you can make an argument that is probably more tedious and inferior on a deployment perspective, on day one perspective. Go ahead, Hal.
Yeah, just I'm enjoying listening to this, but I wanted maybe to insert a thought here, just thinking together with you. I don't think anything has to be this way, right? You can.
No, it doesn't. It doesn't. No.
Yeah, my point is that I can think of two ways to make this process specifically much easier to work with. One is have one code repository on GitHub or wherever, where you include both the specialization code and the operator code in one place, right? So there's no, when you want, so all the code for the network function is integrated in one place, right? Obviously, the code runs in very different places. One code runs on the management cluster, one piece of code runs on the operator cluster. But they can share code. They can share data structures and other things that they need for both parts, right? So you're injecting yourself into the Nefio flow in two different places, but it's obviously integrated, right? So you can ideally, of course, the challenge is how do you test that together, right? So I think that's part of what the SDK can do, can take this single repository and do what it needs to do to like completely deploy your image, right? And also deploy images on both sides, right? You might need also to deploy something on the management cluster, and kind of that you would be able to test and run it all together, because conceptually these two code bases are linked, right? Even though they're running in very different environments, right? The second thing is, I talked about this a lot in the past, but the way we've been using workload operators is the operator does everything, right? It installs, sometimes we call those installers, right? It's an operator that owns all the resources, right? Deployments, services, config maps, etc. And we tend to do that by generating the code in Go, which is, as you mentioned, extremely unwieldy, right? You need to compile it, you need to do other things, but nobody said that you have to write to create all those resources in Go code, right? There are all these projects out there that are not Helm, right? But still use templating and use other generation, and you can make the generation of a deployment or a config map far more lightweight, right, and easier to work with than we have so far. So I guess my point is that I don't think the basic structure of the operational code here is wrong. but we
No, no.
can
So,
do
so,
things.
so the concept, I still believe the concept is correct.
Okay,
That
okay.
we want operators to own. So all this came from, obviously we built this before we built prototypes. John and I built prototypes before even Netfield get launched. And that time we didn't work on 35GC. We worked on a particular vendor's network functions. So that network functions has dynamic configurations supported. So there's some initial configs that you may or may not need, but then you can push that as config map, which is separated. But then the rest of the things like BGP configs and even finding IP addresses, everything other than management interface, if they have any, is it's all done later. It's deferred, so you can deploy it. And then later on, apply configurations. In fact, the argument is you have to use operators, in fact, to in a way to do configurations, because that particular vendor's network functions, what they run is they run an OEM pod on the UPF and SMF and so on instances. And then the one way we can get through them without using the EMS is we have to SSH to the OEM pod and apply a file, apply the configurations directly. And then obviously that isn't Kubernetes. And then we have to do that and then operator way. So what I would imagine is the operator is needed because the channel of communications with the network functions is not necessarily Kubernetes based. It's not CLDs and things,
Right.
and not
I
going through a
think that's
Kubernetes
the
API
point.
server. So
Even
because of
more
this,
than
I
that.
think applying network function configs using operators is still the right idea. It's just so much that 35GC or anything that are open source other than maybe Magma that are usually text-based configurations, and you sort of use mounting your config map, and then they usually have to boot up with the configuration fully populated in a text file. So it was built this way, but then again, if any changes happens, you can see the weakness, and therefore this is why we brought this up. I brought it up in this way, but yeah, there are ways to remedy this, and then obviously we tied it up with the SDK. Otherwise, I wouldn't have presented it here. And okay, so ideally, it would be nice if we can at least make any updates of at least the built-in resources to be templates that are as easy as Helm charts updates. I think that's what we thrive towards, because we don't, Netfield as a community shouldn't be generating something with, I would imagine, fundamental changes that turns out to be, having weakness against the current working model. And then so the part where it doesn't go away is we take a hydrated Netfield CL, it probably more than NF deployment moving forward, and the vendor extension pieces, and that generates, we do that and translate it to something. That translation logic still sits somewhere. And then, so there was, Fiacra is not here, but then right, the last SDK meeting, which actually happened before Thanksgiving, so it's been a while. I actually briefly talked about doing a shift left model, and then the folks that were in the meeting, which not a lot of people, were happy about that. So, but then upon thinking about a little more, that, as Tao actually even mentioned that too, that's a replicated logic between the specializers and operators. Even if we want to shift it to left, the operator has to be locally doing something too. So that's why this, if you want to centralize one thing to do, that would be, I still would probably prefer to put it into operators in that case. Yeah, go ahead. Yeah.
So I'm on record for being a little bit skeptical about putting too many things in the shift left bucket,
Yeah,
right?
of course. Yeah.
And what we're really seeing this coming alive right now is with the service assurance use case,
Okay.
right? Because what else does the operator do? Well, all the day two changes, right? Helm does not handle them well.
Yeah, no.
So exactly, like you mentioned that Free5GC is weird in that it has a text init file and you need to copy it into the machine or SSH or whatever. That's actually unfortunately not weird, right? The point is that many network functions are designed are not designed to be cloud native originally, right?
Mm-hmm.
So they work with more conventional configuration systems,
Mm-hmm.
and many of them use netconf, right, and Yang as their
Mm-hmm.
configuration database, right, because that allows them to work in much broader environments, including higher level surface orchestration layers, right? So we would also need, part of this SDK at some point, a way to a good netconf client, right? So you can
Mm-hmm.
actually do these netconf commands, part of it. But the real trick is what happens on day two. If you have a policy in service assurance that needs to change something in the network function, that is exactly the kind of stuff that you would want to delegate as much as possible to the workload and not handle in the shift left bucket, right? Because
Mm-hmm.
that shift left would involve the complete Nefio workflow almost over again, right? You need
Mm-hmm.
to
Yes.
bump the
Yeah.
package
Yeah. Yeah.
version,
Right.
you need to redeploy, etc. And that's unacceptable for a lot of
Mm-hmm.
service assurance scenarios like
Right.
healing and even scaling,
Mm-hmm.
right? And if
Yeah.
you do that change, you want to make the change in such a way that you're not losing connections
Mm-hmm.
and you're keeping everything running. Only the operator can do that, right?
Yes.
It's kind of like the only place where you can do that is, well, I would say there are two places to do that. One is an operator, which is external to the network function itself, or, and this is something that I mentioned sometimes, operators are not absolutely necessary for this scenario. You could enhance the network function to be more cloud native. That is, a lot of that functionality could be included in the network function itself. The network function could know to
Yeah.
call the
That's the
Kubernetes API.
self-healing. Yeah. Yeah.
Right.
Mm-hmm.
So
Mm-hmm.
it could be like self-orchestrating in a way. The nice thing that the operator does is it lets the network function remain in its non-cloud native structure, and it can work with it very closely to do what it needs to do only in the Kubernetes environment, right? So you're not soiling your network function code with the Kubernetes stuff. You're doing it externally, but
Mm-hmm.
that separation comes with a lot of pain points as well. Uh, Point is, once you solve them, you solve those pain points, right? If you need to SSH into a pod, right, you can't
Mm-hmm.
really do that. But if you need to go into a pod and change an ini file or other things in the Linux kernel inside the pod, and then do a restart or something special and weird, you code that knowledge once, right? And you expose CRD-like declarative facade to it, and then it becomes, you solve it once and it's done,
Mm-hmm.
right? And that's something that Helm absolutely cannot do, right? So in all this story here, we're talking only of a fraction, right? The day one
Mm-hmm.
stuff, which is still very important.
Yeah.
But yeah, just to
No.
keep
So
that.
we are going to talk about day two, but then I was trying to be the original intent of the presentation, which I didn't lay it out, is to even suggest I don't know. I think half of that is SDK and half of that is something else. So that's why I didn't put it into presentations on suggesting maybe there is a final destinations of how we want to converge and then building it out. But it's actually a little more pieces than that. But anyway, so let's go into that first. And then yeah. So this the part where you translate the Nefio cout and the vendor extensions into what is needed for your building resources and particularly your configurations, your network function configurations, is something where if you think about a human deploying a network functions, deploying any workload, actually for that matter, the application owner, net offender in this case, writes the Helm charts. And let's say this is a utopia world, and then the Helm charts doesn't need any specializations. It just kind of worked in your customer's environment. And then all they have to do is provide the inputs to values.yamls, and then it will just work on deployment. Then the human is providing input, and then apply the template, applying the generated hydrated, for we call the generated Helm charts or the generated manifest, and apply them. And so these pieces, we take it out of the human's hand, would be what would be done by an operator. So an operator's role is to take all the manual, well, not all, but as much of the manual process as possible from a human, and put it in code. So that the part where you do the translations is actually something an operator should, or controller code should do. The execution part, which is when the human does the applied of the manifest, is something that you could also separate out. It doesn't need to be done by operator. It could be done by someone else. And if we do it in an operator, which is what we do today, the Helm to operator piece that is done by Ashish and Sandeep would be important, because one would argue that they're the one who would be creating the client code, if you will, that would take the necessary resources based on the Helm charts and make sure that that piece of code that we have, the Nephio piece of code, if you will, that would be taking the Nephio CLs, translating things, enough of the information as an input to the resources, that becomes an input pipeline into this Helm 2 operators, and then they will apply it. Or on the other hand, why not just use Helm, or just use some or other deployment tools? I think there are a lot of Kubernetes deployment tools that are great and very, very mature. That I just don't know where our Nephio should replicate that. We should kind of leverage, and then that goes into SDK side, which is, if we want to validate this, the SDK should allows us to deploy this dynamically. If you're using Flux, for example, then the Helm controllers from Flux is something that you have to deploy as part of this deployment, and then you can specify that, and then SDK will be generating that manifest, or you're taking that manifest as part of your deployment package. So things like this could happen, but then if that's the case, other than this little thing, what would an operator do? Well, the auto operator, just repeat that again, is automating what the human operations pertaining to this, to the operations of the applications of the workload into code. So more specifically, your workload's lifecycle management should be done by the operator. Any of the applications, actually, that is the core principle when the CoreOS people started the operator patterns. And then pertaining to network functions, that means that we have to make sure the infrastructures are ready. It doesn't necessarily mean that the network function operator does the infrastructure preparations, because it probably wouldn't be able to do it anyway. The infrastructure is an infrastructure provider or infrastructure owners. Even on a regular operations, we've spoken with different telco representative of the community, and then they did say that that the infra obviously is a completely different silo for them, and we just have to, the operator may have to validate that this is already ready for them before permitting deployment to happen, for example, and then making sure that it can generate a list of requirements of the infrastructure, perhaps, if the infrastructure is dynamic. And then it tracks, more importantly than any of this, is it's because it doesn't do deployment anymore. So deployment happens sometimes later. Once it said, hey, I validated infrastructure ready, execution engine deployed, and then it just keeps on tracking the states of all the components pertaining to this workload. So unlike 3.5GC, most of the commercial UPFs has more than one pod. So to make sure all the pods are running. And that's vendor specific. What does it mean that all your components are good? There may be some validations mechanisms that you have as a network function vendors. And then you're supposed to report an alert, because the obviously using Kubernetes, I would know if all the pods are up and running. But then whether or not this is functional is something that only a vendor can decide. And that logic should go into the operator. And like any of the Kubernetes operators or controllers would do, the whole point is to reconcile the intent with the current state of the workload. And that's not just day 2 operations, but the most important thing really is the day 2 operations. For us, for Nephio, I think we talked about that earlier, even during one of the SIG2 meetings a while back. The current definitions, and I guess this is basically been my fault in a way. The current NF deployment definitions are very configuration specific. It's a little less intense, a lot more like, do this. This is what it is. This is the IP address. Go apply it into this particular interface. But then there's one particular field that we are kind of proud of that is kind of an intent thing, which is the capacity. So the capacity get written as a application level definitions, and it goes to the operators. And then the idea is different vendors would take that capacity differently and then do something different. Based on me as vendor X would know that for me to do a 1 gig up and 10 gig down means what? SRIV means blah with something else. Then that's based on vendor logic to actually make that decisions. So that's just intent. And then that also turns out to be probably the most difficult things to validate whether or not you actually meet the intent. And we haven't done that, obviously, on InVIT35GC today. That we are, well, we don't have enough test tools, really, to simulate whether or not we're getting close to hitting the capacity. And two, well, our code logic doesn't really hook up to any of this. I would make an argument that probably hooks up with observability pieces. And then that basically means that the metrics and things needs to be exposed to the operators. But the life cycle also goes beyond whether or not you meet the intent. You have to see the health of your applications. So in that case, if a pod gets rescheduled to a different node, you also have to make sure that that node actually is prepared to take on this this new pod get rescheduled, any of the pods, because again, if it's not, well, I said 35GC, so that 35GC means just one pod per network functions. In that case, we want to make sure that the NAT is already loaded when you go into the different node. And then all the corresponding binaries and things are installed onto the node and things like this, right? And then you can upgrade your workload, and the operator is supposed to. The operator may actually get upgraded too, but then once the upgrade happens, the operator needs to ensure that it's still operational with the latest versions. And then obviously the usual scaling up and down and out things that needs to happen. So this is probably much more of a operator type of work that needs to happen. In an SDK perspective, as I said, once we have a more concrete implementations of the observability framework, we may actually expose observability library calls and things for them to subscribe to certain metrics and or able to fetch certain things for an operator. And also that basically means it means a lot more things, and that's probably more of a core SIG2 discussions. I could definitely see that the CLD needs to change. We probably have to do Viva and Alpha 2, where instead of giving them explicit IP addresses, you may have to give them a block. And then we can test it using FreeFiGC, actually, as it turns out. In fact, towards 5GS by default sets up UPF, so particularly for UPF. It sets up UPF as a IUPF and the intermediate IUPF, intermediate UTF, and then all the node whatever UPF, I don't remember what it's called at this moment, and the backend UPF. So one that owns the N3 and the other ones that does not own N3 but only N6 and N4s would be. So that would be one way for us to scale out, but then we still see that as a single UPF instance. For example, so that's an example of what we do. What we can do in terms of trying to see how do we use an operators to do day 2 operations on a scale out on a FreeFiGC, and then in that case, if you create another UPF behind a IUPF, then that UPF locally should not go back to. So our CLD should be structured in a way such that we don't go back to the management cluster to create that other instance. Instead, the operator should be able to allocate IP address, creating NATs, hopefully doing VLAN configs on the NAT, all actually done using an operator. But that's a different conversation, the different discussions off of this. But then the main point I really want to do is made out of this is, I think there is a natural separations between the deployment executions, the deployment built-in resources, templates, and things, even config map templates, and the operator work that needs to be done, which is mainly translating the COUts and vendor extension COUts into what is needed to fully populate the config templates and the built-in resources, as well as obviously tracking to see whether or not the health of your application is good. Don't do any reconciliation yet, but then at least do the tracking. And then for this, one suggestion would be on the SDK front is we execute the SDK, let's say using Helm charts, because Helm is the most common things for all the network function vendors that I know of. And taking that as an input, we would be generating a deployment package, and then we'll be generating a network function package. The deployment, not the deployment package, it's more like an operator package, if you will. So that package would be containing all the little things that needed for the operators. Obviously, it's there. If you use Helm, in this case, we are using Helm. If we offload Helm, the executions to a Helm execution engine, whichever it is, then deployment of that engine is also something that needs to be part of the deployment package, or the operator package. It's probably a better name. And then all the things that requires to bring those guys up. So at the time when you apply this, so in that case, your human operators, our users, would have to load two packages. One package is to get the cluster ready to accept deployment, and then sometimes later they would use an NF package to load the deployment. So it's still true today anyway. So the operators and the workloads definitions, the workload packages are two separate packages even now. So that doesn't change. It's just the SDK we're generating them, and the SDK should be a lot smarter in terms of understanding what the dependencies are and making sure that the package contains those manifests. So when you apply the first one, the cluster would be ready for deployment to happen. And in that case, when you load the deployment package, so this is the deployment time. So this is assuming that the operator package is already in place. That contains the Nephew CL and the vendor extension CLs would be loaded, and then the network function operators is already running. At that moment, there's some business logic that I would argue that you want it to be a little more pluggable. Because we're building SDK, so obviously we want to look at this piece of logic as something that you can easily plug in, and whatever the mechanism, it could be part of the operator by itself. But then this is the separation, because for SDK perspective, building an operator, building the logic of operators, is something that is sort of separated. And then let's say you use a Helm execution engine. It could be any of this. Then you also want to manage the life cycle of your Helm charts. So there are different ways to do that. Obviously, you could just load the Helm charts directly into a package. At that moment, then their config would not apply them. Obviously, they're just charts, and then they would be part of the package. That package get loaded somewhere, and then your logic, the Helm, would be pointing to those charts. Or on the other hand, you could also do more of the flux way, where so that affects users. Users would have to put the Helm charts into a repository somewhere that is accessible by the workload cluster, and then the execution engine would fetch the charts from a repo, and then the input values.yaml input would be generated by the business logic, and then they will apply it that way. So this could be anything. That could be directly Helm. To be honest, it could just be you load Helm directly into the workload cluster. There's nothing stopping us from doing that. And then it could be the Helm operators. from operator SDK, and the Helm controller is from Flux, or it could be actually the Helm2 operator generated client code, if you will, and then it could be any of this. They basically takes the place of a execution engine that takes the input and does the deploy and does the actual real deployment, if you will. Well, Kubernetes is the one that does the deployment, but then you're asking Kubernetes to do a deployment with specifications. An example of using Flux would be, go ahead, Tal.
Yeah, just a very quick point that, as I said before, we tend to treat, or we've tended to treat operators as like installers, right? Something that owns everything.
Mm-hmm.
But we can absolutely have all the advantages that operators give for day two without them owning all the resources, right? So you can deploy everything with a Helm chart, and the Helm chart can deploy an operator that has a very specific role in terms of managing some configuration changes, right? It doesn't have to own all the resources, right? So you can have Helm own all the resources, and one of those resources can be the operator, right? So that's a completely valid scenario.
Yeah. So you can use Helm to also deploy operators. We have, I mean, Netflix has natural deployments to deploy something onto the new workload clusters. Obviously, we can change that. I mean, it's not set in stone. But this is well supported, just running an operator today. But you can use Helm if you want to. If you have consistent model, that's okay too. But anyway, so pertaining to Flux, that basically means the step one doesn't really change. And then, other than the fact that the operator package now includes the Flux Helm controllers to make sure that that does get run on the workload cluster before we do deployment. And then so user still needs to somehow, somewhere deploy the operator first, and then make sure everything runs. And then sometimes later, when the users are ready to deploy it, they'll deploy through our regular hydration pipeline. So by the time we hit here, the CL, the NF deployment, and all the vendor extensions are in here, are now fully populated. So the NF operator watches NF deployment. In that case, that doesn't change. Which then goes into some of your business logic. It could be part of the operators. You can code it inside the operator. You can code it somewhere else, and then the operator has to talk to them. And the job would then be doing a values.yaml type generations. So Fiacra pointed out that we can also put that into config map. So we can just load it in as part of the full repo package, and then or send it into the Helm controllers, and then they would pick up the Helm charts with that config maps and deploy it. So that would be one example where the execution engine, the deployment templates are fully separated from the operators. So now, if you want to upgrade the charts, it's not like you don't change the code. So I'm not saying that you do, but you're changing the code that pertains to the automations of the work. You're not changing the code just because the chart changes. For example, if someone just changed the persistent volume, which Netflix doesn't even touch, and just let it fly, then you may not really need to change any of the code, and all they have to do is upgrade the chart here, and then let it fly, and you don't even have to upgrade this guy. Or if we have an upgraded version of Helm that we have to support a whatever new language or whatever that they added onto the Helm charts, that changes probably doesn't pertain to us, meaning that operator. It changes the chart that is now taking advantage of this new language or new function or whatever from Helm. And then we have to upgrade the Helm controller. That also doesn't change this, but we have to roll out this guy and then roll out this guy. So the separations helps us by, I would make an argument, at least not worse than Helm, because this is not what Helm supports. This is what we are taking some operations from the human, which otherwise would have to be done by human, into code. So this upgrade is our job, so that needs to happen anyway. So if any changes that pertains to this code, obviously you have to take the penalty to roll it out, test it, and all that stuff. So that's okay. But then all this are supported by Helm already. Those changes should be at least equivalent to Helm. So we wouldn't be adding more workload on or more work to the users in compared to like when they previously using Helm. So that's basically the core of what I want to talk about. And obviously, all the day two stuff is something that I would imagine. I'm not sure we'll do that for R3, but then as we ongoing, now the separations has already happened. This is pretty much contained inside here. So and there'll be a lot more frameworks. I mean, observability needs to keep some frameworks. We may have to load more things that we have to support for whatever reasons. I say we need Istio for something. Then all this management and things that we need to expose library functions through SDK to the network function operators or other network functions pieces if they write something separate. We can do that as we go. But then for now, in terms of just day one, my suggestions, my proposal is let's separate out the executions, the templates, and the core logics. The core logics that we really do right now for day one is nothing more than translating the CLs, including vendor CLs, into what is needed for deployment to happen, and two, the part where you track if your deployment is healthy. So those are pretty much the only two things that needs to be done by the operator up to this point. And I would like to see that to be just the one thing that you have to build off of Nephio, and then everything else we'll leverage from somewhere else, and then we'll build. We'll bring it up. Depends on the choices that you have. So this could very well be the operator, the Helm operator from operator SDK. So the whole flow would be more operator SDK based, where the Helm chart is no longer in a repo, but we load it into a local directory. So we may choose to bundle that into a package. That's TBD. But then the workflow that depends on what execution engine you want. We'll do something different through the SDK. So that's the suggestions. Any questions? Because I think that's the last one. Yeah. Comments?
I mean, yeah, I'll speak up. The
Yeah,
one thing, yeah. Sorry, I didn't raise my hand, but
no, go ahead.
things at the same time, which is never super. What I think is, getting direct access to a Helm chart repo, I don't think it will be acceptable for deployment to customers. I think probably it's okay as a prototype, right? But I think what you'll see is that you'll have one guy who has access to Git and charge, right? Which at the moment for us is, I call it the GitOps part of at the moment we use config sync, but it could very well be Argo or Flux, right?
Yeah.
And I think you cannot, what I see in some of the discussion I'm having already with customers is that they just want everything to go through a single GitOps tool and not, in this case, you would have two.
Yeah, I mean so I mean, very quickly. I wonder if Clarion is actually answering your questions. If it is, I can let him do it too. Are you responding to Vim, Kieran?
Yeah.
Go ahead,
I mean, I would have seen in this scenario, in the previous scenario, maybe the Helm charts are more like you'd nearly treat them as a binary deliverable from the vendor. So they would be immutable from that context.
Yeah, correct. My experience, Kiran, is the following, right? I mean, you deploy a GitOps tool on the workload cluster, which let's say is Flux or Argo or config sync, right? What I've seen customers do, right, is that that is the thing that you can access charts or Git or even OCI registries and stuff like that, but nothing else, right? From that workload cluster, you want one guy to access that. And here you would actually, so what I'm trying to say is that we should try to find a mechanism to get that chart from there. Is what I'm trying to get to. Rather than build direct channel to it, because you will probably, that will most likely be, I'm not sure everywhere, but I know at least 80% of the cases that I've been involved in, they would reject it.
I wouldn't have seen that myself. I maybe you're talking about something slightly different, but I would have felt that an OCI registry with container images and a Helm chart repo would run alongside each other, and in fact, it could be the same repository.
Yeah, it's not about the same repository, so that's not what I'm saying. Is the how many people access that?
But
Is
it should be a
how
delivery
many
pipeline from the vendor
different
that
software,
brings them
different
on.
piece of software accessing it is what you're saying, basically. So you,
Yeah,
in this case, config sync and Flux will be both watching a repository, or at least a gig organization. Different repo probably, but yeah, same gig.
So what I'm trying to say is that so because you probably you need a token, you need a bunch of stuff to get it accessed, right? So you want, typically what I've seen actually, I haven't seen anywhere 2 or 3 or 4. I only have seen 1.
Mm-hmm.
You mean tools accessing the repo, or sorry, multiple what's them?
No. So having who is responsible to get information from a chart or from a Git repo or something like that, there is just this, I've never seen more than 1. And I tried, for example, recently in 2 or 3 customer engagements to say, deploy something next to it, and they said, no, it has to go via desk.
Okay.
So I basically agree with that, but I think there's a very simple solution, right? As usual, I'll say it's about decoupling, right? So our access to the various kinds of repositories that we have, and you're right, Wim, that it looks like they're separate. Each of them can be with an adapter code, right? So if you need a specific kind of resource, if it's a chart, if it's a config, if it's a template, whatever it is, we could have like a client API to access it, right? So you request, I need this. I need this chart. Give me the URL for this chart, right?
I'm saying the same thing. So what I'm trying to suggest is to build a solution from which you can basically delegate, or let's say you kind of get that information from that entity that has the access rights, if you will, right?
Right. So, and my point is that if you want to do GitOps for some reason, then all of these adapters can point to Git, right? So, as far as we're concerned, right, the workflow treats each kind of these entities differently, and they could be handled in different things. You know, you might have your own repository catalog, right? Some third-party thing, right? With supporting for Tosca CSARs and charts and a whole bunch of other stuff, where you manage all those resources. You might be managing them in Git, right? And you might be managing it in a database, right? So if all these adapters could potentially point to the same resource, the customer could have a single database, right, for all the resources, right? And all the adapters will point to that. But, you know, for those who have different configurations, then I think, you know, in a lot of greenfield situations, you could potentially create a whole new, you know, source of truth for everything. But if you're working with existing source of truths, your adapter can work with them too, right? And the adapters can also multiplex, right? If you're dealing with different kinds of sites, some of them brownfield or bluefield, some of them greenfield, then the adapter can, you know, according to which kind of deployment you're using, can actually access a different data backend, right? So I think if we decouple,
I mean, to the more slightly more extreme case, I mean, I'm not advocating it, but then if they only want one thing to access the gig repo, we can also replace config sync with Flux, meaning Flux will be the one that does
what I'm saying is you can basically, it's like a proxy. Yeah? You build a
Mhm.
proxy, something like that, right?
Yeah.
So it's I do agree with the principle to reuse the Helm chart as much as possible, right? But so what I'm trying to get to is you cannot have all of a sudden 10 things in the workload cluster.
Yeah, of course, yes.
That was my comment, basically, right? So
yeah, there are ways to remedy this, but yeah, sure. So that's a good requirement for as an input. Yeah.
So, also remember, sometimes workload cluster may have limited hardware resources.
Yeah. I mean, I think Bernard pointed out that even when we make our initial presentation in June. So we're saying that at least you have to access gig, otherwise it wouldn't work. And so what we know is there must be a channel that we can get to a GitHub or some sort of Git repo from workload clusters. Yeah, so that was our major requirements. Everything else is okay, but then you need to remotely access a Git repo that is shared between the management clusters and the or accessible by the management clusters and the workload cluster. So that's always a requirement. So we can use the same repo, if you will, for this purpose. It's just that Vim pointed out that maybe you want to limit what applications or what controller can access that Git repo in workload clusters, and then that's fair. That's a legit requirement.
But I think just to point out, Stephen, I think you can probably start prototyping like that direct, but I think we have to put in place a system by which you can do this proxy or something like that, or whatever.
Okay. Yeah.
Whatever what the mechanisms are that those tools have to be able to get information, right?
Okay, that sounds good. Yeah. So to me, that would be one way to start exploring the Helm support. I for volunteering contributors, I think that would be the initial POCs that we're targeting. Whether or not we want to use Flux versus operator SDK, I guess we can discuss it later. But then the diagram is written in Flux because obviously Flux has user impact. So we would that's why we would like to see whether or not there's any things that is something we cannot resolve or is difficult to resolve. So that's more like a POC thing. And I would also like to see a POC that is more end-to-end from in an R3 timeframe. Supposedly we should ship this thing in R3, so we should have a SDK version 1 in R3. So that's something that we are moving on right now. It's 10 o'clock already. So we can talk about in terms of planning this. Folks that are interested to participate. I mean, there are things that are already existing, like packaging tools and things that are written by Vim that we'll leverage. But then I would like to see more of an end-to-end workflow where now this is actually working. And I think this is nice for more initial support to have Helm support as bundled as part of the SDK. Resolve that problem off of the SDK. So that's my proposal. And then we're 2 minutes over. So anything else? Anyone has any further comments? Oh, if not, thank you.
Yeah, I guess a quick comment. Maybe the agenda for next time. Well, maybe everybody needs to process this a bit.
Yeah, of course, of course.
And we had a few presentations from other people too. I feel like we need to start, like you said, like planning an actual POC. But I think it should be in context of our current use cases, right? Think of something that's actually useful, right? So I've said in the past that really showing. So far, we've done absolutely nothing interesting with operators, right? Other than make things harder, as you pointed out, making it harder to create the resources and deploy them, right? Because we need Go code instead of the Jinja templates in Helm, right? So it's harder to work with. But I think we need a use case, right, to show the community at large a POC that actually does something interesting with an operator for day 2. Right? Showing that the operator can actually do something. So the service assurance use case is the one area we're working on this right now. But I think in ORAN too, there's possibly some use case can come out from there that does something, some sort of self-healing or reconfiguration or scaling. So I think we need to brainstorm about that and try to think of
so between SIG 1 requirements, which is supposed to be submitted by Friday, I guess, for all of us, and then SIG 2, you guys, you and Vim, in terms of prioritizing the kind of work, the SDK will follow that use case for sure. But then I would like to have an end-to-end SDK just to make sure that the SDK can satisfy certain use case. I don't think anyone denied that Helm support is kind of a high priority for SDK, at least like TSC has said so. That's why I kind of bake that in. I have to be honest too. I have a different use case for SDK that are more for work reasons too. That has nothing to do with Helm. So there was something else that I would have to build on the side too. But then at least for community, for sure, for NF and vendors onboarding, this Helm support piece seems to be important. And when we want to do service assurance and we have to bake in day 2 things where we'll be able to expedite day 2 type operations into making it easier for operators to be created to support this. I'm open to that. Let's see how many contributors that we get to build this. But that's definitely something that it'll be interesting. Obviously, I'm also part of the observability team, so that's I would like to get that frameworks and expose things into the operators to make them more intelligent. But then that's different conversations, further conversations beyond just simple day 1 things that we still need to take care of at this point.
Sounds good. Thanks for moving us forward.
Thank you, guys.
Very good. Thanks.
Let's resume talking next week then. See you guys next week. Thank you. Bye.
Thanks. Bye.